Hello, and welcome to Pass the Torque. I'm your host, Katie Caudry. This is your co-host, Gus. Earlier this week, you met Dr. Edward Chung and had a chance to ask him your questions. Today, he's back with some of your answers. I'll let him take it away.
I heard there is a device in space that you invented and called Aruba. Can you tell us a little about this?
Okay, thank you, Israel, for the question. Really have had a long history with NASA, and one of the projects I've worked on is the Hubble Space Telescope. And as you know, we used to visit the telescope for servicing on several occasions and build new hardware and upgrade and repair the telescope. And one of those missions, we realized late in the game that we had a problem, a vulnerability with the hardware, with the system. And so we were tasked with solving this problem. And the problem was quite important because it could cause the draining of Hubble's batteries. And as the electrical lead on the project, I was tasked with solving this problem. Now, early on, I realized there were a couple of neat aspects about this device. It was going to be very important to save Hubble, frankly, in case there's a problem, and also that the device would be sitting on the outside of Hubble, and that the astronauts would be the one to install it. So I decided to name this device the Aruba Box, and actually, I have some pictures that I can show you. If we look at the screen now, this is the Aruba Box during its construction. You can see the sign Aruba on there. And the next image shows it in space. The large round object on top is the Earth. And then we are looking out of the Shuttle cargo bay on this white panel that has the Aruba Box mounted on it. In the next image, you see this panel mounted onto the Hubble Space Telescope. So you can see the Aruba Box sitting there on the outside. In the background, you see the starboard wing of the orbiter, and then in the top you see the curvature of the Earth. So this is one of my favorite pictures of that mission. And here, finally, you see a view from the flight deck of the shuttle. You're looking up at the Hubble, and you can see the Aruba Box sitting there. So the reason I called it the Aruba Box is, as I said before, I knew this would be handled by the astronauts, and actually John Grunsfeld, who installed the system, actually spoke the name of our island over the interstellar communications, if you would. And that was really great opportunity for our island to be recognized. And I really wanted the people of Aruba to realize that they have a really direct link to space, and that the young people in Aruba can consider themselves being able to work for NASA one day if they work on their educational goals and achieve their educational aspirations.
Can you tell us more about other projects you are involved with?
In addition to many years on the Hubble, since then I've worked on several International Space Station projects. And this has been in our next role as our project, which is to study satellite servicing, to study robotic satellite servicing. So instead of using a human crew, using a robotic crew to repair a satellite. And we have been doing a series of these demonstrations called the Robotic Refueling Mission, and building this hardware and testing them on the International Space Station. All these experiments have been used to evaluate technologies to refuel and refurbish satellites, and all this is to feed our larger parent project called Restore, now renamed to OSAM, which is a satellite servicing mission. So in our case, we built hardware for the shuttle to bring to ISS, and then in the future we will be flying our own mission in order to restore and refurbish satellites. And the project is called OSAM.
Do parts in space rust? Does Hubble Space Telescope have to be replaced within a certain period of time to avoid service interruption?
That's an excellent question. It gets at the heart of all the years of work we've been doing servicing Hubble and in the future servicing future spacecraft. But getting back to your original question, it seems obvious to say that there's no rust in space because there's no air. But I think there's more to that question. So we all know about oxygen, which is O2, diatomic oxygen. There's two oxygen molecules stuck together and we breathe it every day, O2. But there's also a second form of oxygen called ozone, or O3, and that's three molecules of atomic molecules of oxygen combined together, and they tend to hang out in the upper atmosphere and protect us from the sun's UV rays. And then yet there's a third form, and it's called atomic oxygen, which is the individual atoms of oxygen split, usually by the UV light of the sun. And this is very rich, although at very low pressure, in outer space. And this atomic oxygen really is a very good corroder. And you talked about rust, which is essentially oxidation or corrosion. And there's the same thing. It's the interaction of the material with oxygen. And atomic oxygen is very volatile, it's very corrosive. And so it will also cause a rust, so to speak. I actually have here some samples of some material that came off the Hubble. It flew on the Hubble for 20 years, and you can see these little silver flakes inside, and that's because the atomic oxygen has degraded the insulation and caused these silver flakes to come off. So it's very corrosive. So this attacks the outside of the spacecraft, of the satellite, because as soon as it comes in contact with the satellite, it reacts and then is used up. So the outside has to be designed appropriately to handle this corrosion, this rust, if you would. On the inside, it's not that affected by atomic oxygen, but as I'll answer in other questions, there are other effects on it, and there is age. So after a while, things do wear out. They get degraded by radiation and will require repair and refurbishment, which is a very big part of how we have Hubble in space for such a long time. Thank you for the question.
Which of all the projects you worked on have you enjoyed the most?
Yes, this is a very interesting question. I think I'm going to really key in on a particular word that you're asking the question, which is enjoy. And I must say that all this developing of hardware, building it, operating in space, including the Aruba Box, for example, is really rewarding and fun. But in the past, my favorite project has been our flight in zero gravity, which is where I spent with a team a week-long mission, floating in zero gravity and on experiencing what it would be like to be an astronaut, to float around, and to experience the magic and the uniqueness of zero G. So that what I would say would be the most enjoyable and fun project I've been involved with.
What inspired you to be part of NASA?
Well, it was luck, actually. I've had a long career, and it was really luck. And I was giving a talk for my doctoral dissertation, and someone who worked at Kennedy Space Center thought it would be a good fit for me. So that's how I got started, and I just happened to have the preparation to be able to accept the job, and I'm thankful for being prepared. But yeah, I'm just very appreciative of this fortunate circumstance.
Tell us more about that car you're sitting in. How fast can it accelerate compared to a space rocket?
Okay, let's explore it a little bit. As I said before, I don't really drive my car all that fast, but we can use test results from magazines and TV shows to understand and relate to its acceleration with respect to a space vehicle. a little bit of math first. Let's first explore this with some math, and we know that a common performance metric of cars is a 0 to 60 time. Now my car accelerates to 0 to 60 in 3.3 seconds, so that's one way we can assess its acceleration. Now 60 miles an hour happens to correspond to very close to 100 kilometers an hour, and so 100 kilometers per hour, we really want to get to meters per second, so 100,000 meters per 3,600 seconds means that we're at a speed of 27 or 28 meters per second. Now our gravitational acceleration, or the G, is 9.8 meters per second squared, or let's give it more or less 10 meters per second squared to round it up a little bit. So it takes about 2.7 seconds at 10 meters per second squared to get to 27.7 meters per second. So 1 G of acceleration would take a car to 60 miles an hour in 2.7 seconds. So my car could do 3.3, so its acceleration is not quite as strong as 1 G. So that's one information. The next thing we can look up readily is the acceleration of the space shuttle. And as you can see in this graph, with my car in the blue line slightly less than 1 G, we can see that the space shuttle accelerates in times 4G, or about 4 times as much as my car. So clearly the space shuttle is much quicker and higher acceleration than a car would be, and any car would be. Even a top fuel dragster wouldn't hit 4 Gs.
What is your favorite part about your job?
Yes, as I keep saying, I hope I'm not repeating myself, I've had a very fulfilling career at NASA, and I've done all kinds of things, been inside the space shuttle, and it's been a really wonderful couple of years. But I honestly have to say that my proudest moment of this job is not what I've done. It is what our organization, NASA, has done. For example, 2 weeks ago, we had the 50th anniversary of the Apollo 13 mission, and we all know its story and how that ended and how NASA really pulled together to save these 3 crewmen. We had a special screening arranged by NASA to the NASA family of the movie Apollo 13, which is one of my favorite space movies, actually. And I really felt privileged to be sitting there watching the movie and to feel part of this team. Obviously, these men, this story played out when I was a young boy. I can't take any credit for what they did, but I see in how they worked the way my co-workers work on a day-to-day basis, solving problems. So I really feel that we are representing the drive, the means of solving problems that these men showed during that mission, and I feel really proud about that. So basically, I feel really proud to be a very small part of a very big thing, and that's the main thing that makes me proud and makes me happy, that I am a very small part in a very big and storied and historic and amazing organization such as NASA.
Thanks so much, Dr. Ed. And thank you for some really great questions. Make sure you join us again next week to meet another one of our NASA engineers. See you then.
So one of my hobbies is pinball machines, and this is my collection here. My oldest machine is the one I started with. It is a space shuttle. Its pieces have been signed by various astronauts that I've worked with. It's been signed by mission flight director Gene Kranz, Gunther Wendt, and others in the Apollo program. We have a whirlwind, which is a hurricane theme. It has a fan that blows on you at certain times like a hurricane. Of course, we talked about the space shuttle. My next machine here is called Medieval Madness. It has a castle that blows up with a drawbridge and gate and all that. It's very lively. And then lastly, along the row here is my Twilight Zone. This one is very heavy with all kinds of toys and ramps, including additions I've made. It's a very well-known machine for people to modify and enhance. This is my collection.